Hello viewers, this is Mahmood, and in this video we are going to solve another past paper question. And the question is, the rate at which a body cools is given by the equation d theta over dt equal minus k times theta, where theta is the temperature of the body above its surroundings and k is a constant. So in the first part, we have to solve the equation for theta, given that theta equal 150 degrees Celsius when time t equals 0 and theta equal 70 degrees Celsius when time t equal to 10. In the second part of the question, we will find the time taken for the temperature to reach 20 degrees Celsius. Okay, so now first we are going to solve part first of this equation. So the given equation is, that is d theta over dt is equal minus k times theta. So now it's clearly a differential equation. So by separable of variable, we can solve this differential equation for theta. Okay, so this can be written as 1 divided by theta into d theta equal negative k times d theta, okay, by the differentials rule. Now we are going to integrate each side. So the integral 1 upon d theta 1 upon theta into d theta equal negative k times, here apply the integral negative k into d theta. Now you can see the derivative of theta is 1 with respect to theta, that is present in the numerator, so we will take the log of the denominator. So that is the natural log of theta is equal minus k times minus k is a constant, so the integral of 1 with respect to t is basically t, and then you have to put the constant of integration, let's say that is c1. Okay, now we have to use the exponential form, so this can be written as theta is equal e raised to the power minus k t plus c1. Okay, let me explain this one. So if we have log of let's suppose log of x is equal to y, so this is what we call the logarithmic form. So in exponential form we can write just like e raised to the power y is equal to x. Okay, so the same here. So instead of theta, instead of x here we have theta, and instead of y we have here that is y. Okay, just compare with this one, so you will get theta equal e raised to the power minus kt plus c1. Okay, now we can write this in this form: theta is equal e raised to the power minus kt dot e raised to the power c1. Okay, because the bases are same, so we can add their exponents to get e raised to the power minus kt plus c1. Right, so here let's say e raised to the power c1 is a constant, so let me denote this by capital C. So the final result is going to be theta of t, because it is a function of t, so theta of t is equal c times e raised to the power minus kt. Got it? So this is what we call the general solution. Right, so now we are using the conditions. So the first condition is theta is equal to theta is equal to 150 degrees Celsius and when time is 0. So putting these values in the general solution, so here we get theta into 0 equal c times e raised to the power minus k, and t is 0 here. Okay, so now putting the value of theta at 0, that is 150 degrees Celsius, so that would become 150 is equal c times, and now e raised to the power 0 is 1. So we got the value of c, that is 150, right? So putting back this value again in the general solution, so you can see, so the general solution would become theta of t is equal, sorry, put the value of c here, that is 150 e raised to the power minus k into t, right? Now we are using the second condition, that is when time t equal to 10 and theta is 70 degrees Celsius. That is when time t equal to 10, then theta is equal to 70 degrees Celsius. Okay, putting this value again in the general solution, so now you can see here theta of 10 is equal, and what is my c? C is basically 150, so that is 150 e raised to the power minus k, and now you know the time t is 10 here. Okay, so now theta of 10 is basically 70 degrees, so that is 70, and divide by 150 here, so 150 is equal e raised to the power minus 10 times k, right? So now by simplification, we got 7 divided by 150 is equal, 7 divided by 15 equal e raised to the power minus 10k. Okay, again use the logarithmic property, you know, this is an exponential form. So when we write this in the logarithmic form, this can be written as, you know, log of, that is going to be minus 10k is equal natural log of 7 divided by 15. Is it okay? Now dividing each side by negative 10, so the value of k would become just minus 1 divided by 10 into natural log of 7 divided by 15. Okay, so now calculate the value of log, that is the natural log of 7 divided by 15, so that is going to be k is equal, so minus 1 divided by 10 is basically minus 0.1 times log of 7 divided by 15 is minus 0.7621 approximately. Okay, now we will multiply this with the negative 0.1, so it is going to be k is equal 0.07621. okay, so this is the value of k. So now putting the value of k and c in the general solution, and you know that our general solution was theta of t is equal c times e raised to the power minus kt. Okay, so this solution will become, you know, theta of t is equal, our c was 150 and e raised to the power now minus k, the value of k is minus 0.07621 into t. Is it okay? Now the second part of the question is we are going to find the time taken for the temperature to reach 20 degrees Celsius. So our theta is here, that is 20 degrees Celsius. So putting the values in the above solution here, so theta of t would be 20 is equal 150 e raised to the power minus 0.07621 of t. Okay, divide each side by 150, so it would become 20 divided by 150 is equal e raised to the power minus 0.07621 t. Now simplify each side. So on the left side it would become 2 divided by 15 is equal e raised to the power minus 0.07621 t. Now again we are using the exponential to logarithmic form. So now it is an exponential form. So in logarithmic form this can be written as minus 0.07621 t is equal the natural log of 2 divided by 15. Okay, now divide each side by the coefficient of t, so it would become minus 1 divided by minus 1 divided by 0.07621 into log of 2 divided by 15. So this is going to be minus 2.01490 approximately. Okay, so now t is equal, simplify these two factors, so just it is going to be divided by 0.07621, so that is going to be plus 26.43 or 44. Yeah, so you know the time is 26.4, then the temperature reach 20 degrees Celsius. Okay, so this is our time. So when the time reach, or you can say the temperature reach to 20 degrees Celsius, so the time taken would be 26.4